In the last lecture, we have achieved objective number 1. The first objective from our algorithm, that is a function that will ask the user to enter a target network range over the terminal. So we have achieved that. Now in this lecture, we are going to go ahead and try to achieve objective number 2, the second objective. That is a functionality that will scan the network and get all the hosts that are connected to that particular network. And that is this map to in our program plan with the number 2, that is a function to scan the network. All right, so we are creating a function that will now scan the network given the target network range that the user has specified over the terminal, which we were able to get that in the last lecture. Right, so let's proceed. I'll go to the file that we scripted in the last lecture. So now we are going to create the second function to now scan the network. All right, so let me all right, so now I'm going to specify the name of the function, def, a keyword that I'm going to create a function. Now let's call it scan target. So basically this is a function to scan the network. So, and then I can put my comment. It's always good to document your code so as to help yourself later when you come to review the code, or anybody that want to use your code will know what the lines of code, what they are achieving. So a function to scan the network, a function to scan the network. Right, so all right, so and then put a semicolon. All right, so let me delete this. All right, so now I'm going to start scripting. So basically here, what we are going to do here, we are going to create a ARP packet. So we are going to create an ARP packet. We have already seen what an ARP is, address resolution protocol, and how the protocol works. So basically we are going to create an ARP packet that will be broadcasted over all the hosts that are connected to our network. Given the network range, it will iterate over all the hosts and then make a request to them and then get their response and get their given the IP, because when the target specifies the network range, then this particular scan target will now go over those IP addresses, asking for their MAC addresses and get their MAC addresses, and then so now we have the IP address, then request for their MAC address, and then we have both the IP address and the MAC address. And to achieve that, we are going to create two packets. First of all, we are going to create an ARP packet for making the ARP request, and then a broadcast packet that will make sure that the packet has been broadcast, has been transmitted to all the hosts that are connected to that network range. Then we combine the two together to form an ARP request, broadcast ARP request. All right, so the first thing we are going to do, and to create a packet, we have a module called Scapy, which is used extensively in creating Python-based hacking tools, and which we shall also make use of, in this particular lecture. Okay, so I'm going to import Scapy .all. All right, so the name of the module is Scapy.all, and then Scapy.all, and if you wish to import it, we import it as Scapy.all. All right, so the name of the module basically is Scapy, and then we want to import it, we import it as Scapy.all. But still, I want to reference it as Scapy. So to do that, I can make some little additions as Scapy. So I'm telling my Python interpreter to import a module called Scapy.all, but in my code, I wish to reference it as Scapy. So whenever I say Scapy, I mean this module Scapy.all. Okay, so now I can make use of it. And then what is it, this module, what is it meant for? I'll add a comment beside it so that whoever see it know that what this module is all about. So for packet crafting, so it is basically used in crafting packet. So for packet crafting. All right, now I can go down and start making use of it. So the first thing we are going to do, as I have said earlier, we are going to create an ARP packet. So I will set ARP request packet. So ARP request. So let's call it ARP request packet, ARP request, and then I'm going to using the module Scapy. Now from in that particular module Scapy, there is a class called ARP. All right, address resolution protocol. So now basically what I'm doing here, I'm creating and I'm instantiating an object of class ARP, and that object is basically an ARP packet. So instantiate an object of class ARP, and which basically is a ARP packet. So it is an ARP packet. All right, so which is basically an ARP packet. So scapy.arp. All right, so and then now I need to we have the ARP, but there is some layers, some fields within the ARP packet that we need to specify, because this is just an empty packet now that we have created, but we need to specify the packet. We need to specify the destination where this packet is going to be sent, because this is an empty packet without specifying any destination. Because and we can show that, because we can this ARP packet and has a function called show. So I'm going to reference that function .show, ARP packet .show. Now this will now show me all the fields that are contained within this particular ARP packet. All right, so ARP packet .show, and now I'm invoking that particular function. Now when I call this when I invoke this function, we are going to see the various fields within this particular packet. All right, so now let's invoke this. So print get target. Now and then also this particular function scan target, when we invoke it, we are going to define a parameter, so that whenever a line of code invoke it, that parameter is going to be passed as an argument. So whenever scan target, when we invoke function scan target, we need to give it the target that is going to scan. So let's say target. All right, so now as I invoke it, now I can just invoke it, I'll just write the name of the function scan target. Now but I need to give it as an argument, which is the target network that is going to scan. So we know that get target will get the target. So let's let me remove this print. So and then we have what take So we have the target that the user is going to enter over the terminal. Target equals to get target. All right, and then we know that let's go back to this function get target. We know that it's going to return option.target. All right, so and then that option.target, we are going to give it to this particular function scan target, so that scan target will scan it. All right, let me save it. Now let's run it so that we can see what this ARP packet.show is going to show us. So I just go to the terminal and then navigate to that particular directory, cd desktop lectures. Clear the screen and then sudo python 3 and then python 3. Then the name of the file is hostscanner.py, and then I'm going to specify a target. Let's say 10.0.21, which is the device that I want to scan, and then let's see. All right, let's see whether it's going to work. Okay, so I'm having some issues here. ARP packet is not defined. Line 29 and line 34. Okay, so line 34 ARP target. Okay, so let me go back to the code and see what the issue is. So we have ARP, okay, ARP request. Yeah, I didn't write the name properly. So ARP request, ARP request. So let me save, and then let me go back again. Clear the terminal and then run the program again. All right. So as we can see, ARP request.show has given us all the fields within that particular packet. And then we can see that this 10.0.2.9, which is the source IP, which is the IP address of this particular machine, that Kali Linux that we are working on. Then a destination IP has not been specified, which is the pdest 0000. So we need to specify the pdest field here, so that to match the network target that we are scanning. So we are scanning 10.0.2.1. So it need to be reflected in this particular field pdest, so that the packet knows which device it needs to send that ARP request to. All right. So we go back and then set that particular field. So skp.arp, and then we can just come here within the parentheses and then set that particular field. Pdest equals to assign it to the target. All right. Then I will save it, and then now let's run it and see whether has that field been set. Then run it. All right, as you can see, it has been set in the pdest field 10.0.2.1. So basically, we are making an ARP request to this particular device with IP address 10.0.2.1. So the ARP request packet know where it is going to be sent to, which particular device is going to make ARP request to. All right. So now let's continue scripting. So we have done with this method, so I'll just delete it. Now next we need to create a broadcast packet, because after creating the ARP request, we want to make sure that that particular packet has been broadcasted, has been sent to all the devices that are on that particular network range. Though in this case we're just specifying one target, but in a situation where the user of this particular application set a network range instead of just a particular single host. All right. So for that, we need to create a broadcast packet. So I'm going to create it, a broadcast, the name, which is just a variable name, broadcast. And then now I'm going to invoke from this module, skp, a particular class called eta, which is responsible for creating a broadcast frame that will be transmitted to all the devices that are connected to a network. And we don't know the fields in this particular object broadcast. Now we can also show it using function show. So broadcast broadcast.show. So let's see the fields that it contains and which one do we need to set. So I will save it, and then I will go about the terminal again and then run this particular script and see the fields that are contained within that particular broadcast packet and what we need to set. All right, as you can see, we have dest, which is the this particular in hexadecimal notation, which is the destination MAC address of this particular dest. Now we need to go and set dest. If we are sending it to one particular device, a single device, then this dest, we are going to specify the MAC address of that particular device. But in this case, we are sending to all the devices on a network. So if the user of our program specify a network range, we want the ARP request to be sent to all the devices that are connected to that particular network range. So for that, we need to set dest as the broadcast MAC address. So this FFF is the broadcast MAC address. So yes, broadcast MAC, the MAC address of a broadcast packet. Okay, so I'm going to copy this, copy it, and then go and set it in that particular packet. So I'll just come here and then under the dest field, under the dest field, is the dest. dest. Okay, so I'm going to set it as the broadcast MAC address. So I'm telling the application that I want to send it to all, not just a single device, to all the devices that are particular connected to the network range that the user of my application has specified on the terminal. Okay, so I didn't set it properly. Sorry, it's not supposed to be here. X, control X in this particular class. So I'll set it here. Now I can clean this. Okay, so now we have set it. Now this particular packet now broadcast will be broadcast since the destination MAC has been specified as a broadcast MAC. Now it will be sent to all the devices that are connected to the network range that the user of my application has specified over the terminal. All right, now we are going to combine this to make up an ARP broadcast packet. So in this, instead of this ARP request being sent to only a single device, it will now be sent to all the devices that are connected to that particular network range. So for that, I'm going to call it broadcast ARP request. ARP request, and then to combine it, I will just write broadcast and then put a / and then ARP request. All right, so now I've created a broadcast ARP request packet. Also, this we can show it using the made function show. So broadcast ARP request dot show. Let's see how the packet is going to look like. Right, so I can go back and then the terminal, run it and see how it looks like. So just hit enter. All right, as you can see, this is a 2 packet combined into 1 packet. The destination is the destination MAC, the broadcast MAC. That means going to be transmitted to all the devices on the network, and because the user of the application has specified pdest, so the IP address is just 1. So in case the user enters in a network range, then the destination IP instead of 10.0.2.1 is going to be the network range that the user specified, and this is a broadcast packet. Is now going to be transmitted to all the devices that are on that particular network range. All right, so I'm going to clear the terminal again, and then there is also another function called the summary that will just give us a brief information about that particular packet. So instead of giving us a detailed information about the various forms within that particular packet, just give us a summary of the packet. So let's run it and see. All right, so summary. Okay, so the summary, where the summary. Okay, let me print it out. I need to print it out. I couldn't get any output. Print broadcast ARP request the summary. Let's print it out and see how the output is going to looks like. So run it again. All right, as you can see, this is basically a summary of how the packet looks like. Ether ARP, who has 10.0.2.1, says 10.0.2.19, which is our machine. Now going to that particular host, making an ARP request. And now this 10.0.2.21 will now reply with its MAC address that I am 10.0.2.1 and my MAC address is this and that. Okay, so now we have created the packet, but we didn't send the packet. We have created an ARP broadcast packet, but we didn't send the packet. So we need to send the packet. And to actually send the packet, there is a SCAPI function called SRP. So we are going to make use of this SRP packet, and this SRP packet, it is going to send packet and also get reply. So it's called send response packet. It will now send a request packet. Send the request packet is going to send the packet, which is our broadcast ARP, which is the broadcast ARP request that we want to send. We are going to make use of the SRP function to now send it. Now after sending it, it will also get a reply for us. So it will not just send the packet and then forget about it. It will send the packet, and then whatsoever device it send the packet to is going to get the response, and then give us the feedback it got from that particular device. Okay, so now what are we sending? We are sending our broadcast ARP request packet, and then we need to also specify another parameter called timeout, so that after waiting for that particular amount of time, we want it up, and if it didn't get any response from that particular host, we don't want it to wait until it gets response. It should forget about that device and move on to the next device. So I'm going to specify 1 second. So just after reaching out to a device, after 1 second I didn't get any response, then forget about that particular device and move on to the next device in that particular subnet. So okay, so let's run this and see. Broadcast SRP. Okay, so with SRP broadcast packet. Okay, so after this we're going to get a response, and going to the documentation of this particular SRP. Now from the documentation of this particular function, SRP function send receive packet, we can see that this particular packet will return two lists, which is answered and unanswered packet. Answered and unanswered packet. Now the first list answered packet is actually a couple, which comprises of the packet sent and then the answer received. So and then so basically this our SRP function, when it runs, is going to return two lists. The first list is the packet that we is the answer that we receive, and that particular answer, that the response that we receive is in couple, the packet sent and then the response that we receive, while the other list comprises of the unanswered packet. Okay, so and to get these, but we are only interested with the answered packet. That is actually the devices that responded back to us. So we want to, and then from there we will be able to extract their MAC addresses. Okay, so and the IP addresses and their MAC addresses. So what we are going to do, we are going to create a variable and then just name it answered packet. So answered, or since it is a list, let's call it answered list, and then assign it to this particular function SRP. And then how can we get that answered list? Since it is the second list, it is the first list rather that returns, which is basically a couple, the packet sent and the answer received. So using this square bracket 0, we are telling it that we are interested only in the first list, which is the couple that contain the packet sent and the response received. So this is the answered list, and we can also print it out. Let's print it out and see how it is going to looks like. So let me print it out. Print answered list. So answered list, and see how it is going to actually look like. Okay, so I will go to over the terminal again and then run this particular script. Okay, so let me clear the terminal and then run this script. Okay, SRP is not defined. SRP is not defined. Okay, so I have some issues here. SRP. Okay, so we didn't use the scapy module to reference it. So it is scapy dot SRP. Okay, so it is from module scapy. So scapy.srp. Okay, so now I can go back and run the code again. So let me clear the terminal. Clear terminal and then run it. Okay, so hit enter. All right, so as you can see, we have received one packet, got one answer, remaining 0 packet. So the program runs successfully, but it's not giving us much detail. So let's invoke this function show on it. So answered list. But basically this is a couple, so we won't have any we can't run function show on it since this is a couple, not a single packet. All right, so but we are going to see what we are going to do. This is answered list, which is a couple. So to do that, let's use for loop to iterate over the answered list. So I can say for packet in answered list. So I want to iterate over this particular packet, or packet and answered list. What do I want to do? Since this is a couple, I will just want to print out the packet, the first the second packet, which is the response that we receive. Or I can print both the 0. I can print both the packet sent and the answer received. So, and then print packet.0. Or okay, let's print it out first, and then also I can print the other packet, print packet .1, and then okay, so let's print them out and see how they are going to look like. Okay, so let me go back to the terminal again, and then clear the terminal and then run it again. All right, as you can see, this is how it looks like. Receive 1 packet, got 1 answer. So this is the packet that we have. Okay, it's not clearer. Let's try to make it clearer. Let me put some demarcation so that we can see which is which. Okay, so print, I can put some stars to separate the two, because we're going to have 2 packets sent and then the response that we received. Okay, so let me run the program again and see how it's going to look like. All right, so you can see this is the first segment comprises of the packet sent, while the other one is the response that we receive. Okay, so then we can run function summary or show over it. Let's run function show over it, and then also the show, and see the various fields it contains, detail information about the various fields it contains. So just the packet contents. Let's see how it looks like. All right, as you can see, this is the first packet, which is the packet sent. We can see it is going from 10.0.2.19 to 10.0.2.1, and then the response that we receive. Though I don't have any MAC address. I don't have any. Okay. So we can. This is the response that we receive. It's at. We can see it's at 10.0.2.1. From this is the source, and then this is the destination. This is the. We can see that the source is that 10.0.2.1, which is the device, which is the host that we send the ARP request to. Now it is responding back to our Kali machine, that 10.0.2.19. So the source IP is the 10.0.2.1 that we specify over the terminal, and then we can see the response. Okay, and we can also run the summary function to see just a summarized output from emanating from the packet. So let me clear the terminal and then run show. Summary rather. So I'm going to print the summary, summary, and then also here the summary. So this for the summary and the show are just functions within SKP that will give us information about a packet. So run it and then see information, just a summarized information about the packet. Okay, so as we can see, this is the packet sent. ETA ARP who has 10.0.2.1 says 10.0.2.19. So this is our machine sending an ARP request to a machine with this particular IP, and then this is the response. ETA ARP is at, then this particular machine 10.0.21 is giving its MAC address to our machine, so it is sending the response. So this is the packet sent and then the answer received. So now we have seen a way to assess the packet sent and the answer received. So that is why we say this answered list is a couple, that is a list containing a couple, a packet sent, and the answer received. So we were able to get access to the packet sent using square bracket 0, and then the answer received, which is the other part of the couple in a list, is the word.1. So a couple is also basically a tuple which contains 2 elements. Okay, so as we can see from the terminal result, we can see that the first packet is the packet sent, which you can see it is an ARP request. ETA ARP who has 10.0.2.1 says 10.0.2.19. 10.0.2.19 is our Kali Linux machine with this particular IP address, and it is sending an ARP request to this machine with this particular IP. And we can see that the second packet is the response from that particular machine. ETA ARP is at this MAC address 52.54.00.123.500 says 10.0.2.1. So this, we can see that, and as this confirm what we said earlier, that what the documentation says earlier, that this will return the first list, return two lists. The first list, which we are able to reference with this square bracket 0, is a couple, where the first list with 0 and 0, because we know that a list starts with index 0. So we are referencing the first list, so we have access to the first list. And then that first list is also a couple, a tuple comprising which comprises of also two elements, two packets, a packet sent and the answer received. And we're able to reference the first packet using the first element, using also square bracket 0, which is the first the packet sent, and also to get the response we use square bracket 1. And packet is the element we use for loop to iterate over this answered list, which is the answered list, which is the list that contain a couple, packet sent, and the answer received. Okay. So also we can, if you all right, so let's proceed. I can now clean this because we don't need to print anything at this particular moment. Our aim is not to print anything. We want to be able to, we know that to have access to the packet sent, we are going to get the okay. All right, so let me go back to, all right, let me all right, let me undo it. Undo paste. All right, so let me go back to .show again, because we just want to get the IP address and the MAC address, because that is what we are interested in. So .show and then .show. Let's see the fields that will enable us access the IP and the MAC address. So let me run it again. Let me run the program again. Let me clear the terminal. Then run the program again, because we are just interested in the IP address and the MAC address. Okay, and also we are interested in the not in the packet sent, but in the answer that we receive. So let me clean this. Let me do away with this. Save it. We are interested in the answered packet, not in the packet sent. Okay, let me clear the terminal. Run the program again. All right, so this is the response that we have, and we are interested in it. We are interested in the MAC address and the IP address. So this is the particular station that we send an ARP request to. This is the source PSRC field, specify the IP address, the source IP address, and then HWSRC, specify the MAC address. So we can reference the IP address, the source IP, and the source MAC using these particular fields. So and print them out. Okay, so let's see how we can reference it. Packet 1 dot print packet 1 dot PSRC. Now this will print out the source the source IP, and then let's use a let's print some demarcation, and then followed by the, okay, let me use a star. We want to print the IP and the MAC address, so let me just copy this, and then I can change the fields. So we're just interested in the response IP address and the MAC address. So and then HWSRC, and then I'll save it. Now let me go back and run the program again. So clear the terminal, run the program. All right, so as you can see, we are just interested in the source, in the response packet IP address and the MAC address. Okay, so so we know that now using this particular reference, we can be able to reference the source IP and then the source MAC. So let's create a list, a list, a list of dictionary, that is a list whose element is dictionary, and then populate that dictionary with the source IP and the source MAC, and then assign and then populate the list with the dictionary. Okay, so basically what I'm saying, we are going to create an empty list. Let's call it host list. List. Okay, and then I'm going to assign it to be an empty list. So here I'll say that create an empty list. Create an empty list. Okay, so I'm creating an empty list, and then I'm going to populate that list with dictionary whose elements are the source IP and the source MAC. So here, after iterating each packet, get the source IP and source MAC, and then assign it to a dictionary. So I'm going to create a dictionary here, and then host dict equals to a dictionary. So we use a square bracket to create a dictionary. Okay, so and then I'm going to populate this dictionary with the source IP. So I can see, we know that this particular reference the packet, the source IP. So packet 1.psrc. Okay, now okay, so we know that dictionary goes with what you call a key value here. So the key is IP. The key is IP, and the value is the IP address. And then next I'm going to specify the MAC, address, and then I'm going to reference that with the, and we know that this refers to the MAC address of the response packet. Okay, so I'm going to assign it. The key is MAC, and then the value is the MAC address of the response packet, and this particular key is IP, and the value is the value of the key IP is the IP address of the response packet. Okay, so I can delete this one, I can do away with it. So I have populated this dictionary with the IP and the MAC address of each packet. So this for loop will iterate over the packet in the answered list. Then from that packet, get the source IP and source MAC of the response packet. But if I want the source IP and the response IP of the packet sent, then I'll put 0. But we are not interested in that. We are not interested in the packet sent. We are interested in the response that we receive from the host, from the devices that we sent ARP request to. So that is why I'm using 1, not 0. All right. So now host dict. Now after getting the dictionary, now assign it to that particular list that we created. So host list. So I'm saying host list, list, which is the empty list that we created, and then using it is method called append, and then assign it. What are we assigning? We are appending what? Host dict. So we are populating it, populating the list, the empty list now with the dictionary. So this is a list whose elements are dictionaries. Okay, so this is the list contain dictionary element as the members of that particular list. And then eventually, after running the program, we want the program to return that particular list. So any line of code that call this particular any line of code that invoke this particular function, we are going to return this particular list that contains the response packet IP address and MAC address. So return host list. All right, so now we can our function is complete and it is achieving our objective. So now let's invoke the function and see proper how it works. So this is target, get the target, and then scan the target. Our function scan the target will now scan the target, okay, this function scan target, and then scan target, we invoke it in scan target, and then basically it's going to return the host list. Okay, so now let's create a variable to now assign it. So let me call it host result. Okay, or let me just call it host host, and then so that the whatsoever this scan target function return with, the value is going to be assigned to this variable host. Okay, now I can do whatsoever I want to do with this. So let me print it out and see how the host looks like. Okay, so and then I'll go back to the terminal and then run the program again. So I'll clear the terminal. Okay, now I'll run the code. Okay, I'll run the script and see the output that I'm going to get. All right, as you can see, this is what we are able to get. Since we only specify one target, one client, so we have the IP as 10.0.2.1, and then the MAC address also. The MAC address has been given to us. Okay, so now what if we specify a range, not a single target? Okay, so 10.0.2.1 over using the CIDR notation. Let me give in the whole subnet as the target of my scanning. So let me see the output that I'm going to get. All right, so we see begin emission, finish sending 256 packet, receive 3 packet, got 3 answers. Okay, and then this is what we are able to get as our result. Okay, so we can still improve on this code. We can do away with this particular noisy output. We don't need this. Okay, so let me go back to the code and see what I can do to get rid of that particular output. I don't want that output. So I'll go back to the send request packet, which is actually sending the packet, and then there is a parameter called verbose. So I'll make it verbose. By default it is true, so I'll set it to false. Okay, so I've set it to false. Now if I run the code, I will not see that particular noisy output. Okay, so let me go back again. Let me go back one step at a time. Let's run it and see the output. Has that particular noisy output gone away? So run it again. Okay, as you can see, that noisy output has actually gone.